Convection on Earth. I could recognize that the sun provides energy that drives convection on Earth. For your starter today, which city most likely experiences decreasing temperatures during the next 24 hours? So, first you have two fronts. Here you have a cold front, and here you have a warm front. So if we're looking for decreasing temperatures, we want to focus on the cold front. The cold front is going to move in the direction of the tips of the triangle. So your cold front within the next 24 hours is going to hit Minneapolis first because that city is closest to the cold front. So Minneapolis is going to have that cold front approaching within the next 24 hours. Here, if we were to look at this warm front, this would bring warmer temperatures, but still you'd have rain and storms. You have a low pressure system here too that's showing you that you have that lousy, stormy weather. Atlanta is where that warm front would be approaching because this frontal system moves in the direction of those semicircles. Read the teak below. Identify the three types of fronts you would find on a weather map. So we're identifying how global patterns of atmospheric movement influence local weather using weather maps that show high and low pressures and fronts. So this would represent a stationary front where you have a warm, cold, alternating symbols. In a stationary front, that's where you have the warm air mass meeting the cold air mass, and neither air mass has the strength to overcome one another. So it's a stationary front where you're going to have the same conditions for days. So rainy weather for days. This is a cold front. Cold fronts bring cooler weather, and it's usually severe stormy weather. Warm fronts bring warmer temperatures, and you still have storms and rain. They're not as severe as your cold fronts. So, if we were to look at a map of the United States, what type of air pressure system and frontal systems are located on the northern part of Texas? So, here is Texas. Here we have a low pressure system. Remember, low pressure, lousy weather. So, you're going to have storms, winds, rains. Okay, and then the frontal system that's over the northern part of Texas is a warm front, and this warm front is just leaving the northern part of Texas. What type of frontal system is over the northern part of Florida? What type of weather would you expect? So here's Florida, and we have a cold front moving towards the southern part of Florida because that cold front is going to move in the direction of those points of the triangle. So Florida should expect to have cooler temperatures and severe weather. We also have a cold front up here in the north, and this cold front is moving over the northeast. Low pressure system means lousy, lousy weather, storms, wind, could be violent storms. This high pressure sign way out here, high and dry, you're going to have clear skies where you have the high pressure symbol. All right, we're going to talk about convection now. We're going to talk about three types of convection on Earth. Earlier in the year, we learned about convection that happens inside the mantle of Earth. This is what moves the plates, plate tectonics. So the mechanism responsible for the movement of plate tectonics is convection. It takes place in the upper mantle or the asthenosphere. And I am not going to play these videos during this presentation. I will in class because some of these videos won't upload. So I'm going to move forward with the presentation. And we're going to look at convection on Earth. So here is where we have thermal energy from the sun. It causes warm air to rise and cool air to sink. This creates convection in the air, which creates wind. again, from warm air rising and cool air sinking. Land tends to heat up faster than water, so you have the warm air rising over the land and the cool air sinking over the sea, making this connection, causing breezes. Again, I will play the videos in class. So convection on Earth, we're going to look at convection in our oceans. So this is where you have warm water rising near the equator and cool water sinking in your poles. So here you can see this red band is representing the warmer ocean waters, and then the cooler ocean waters sinking. So the relationship between convection currents and weather. Weather is created by less dense air rising and more dense air sinking, resulting in a transfer of heat. So that's the difference between convection in the air and convection in the ocean. So today we're going to have a note-taking form. So in your assignment, you may pull that up, and we're going to look at the sun, winds, and ocean. We're focusing on recognizing that the sun provides energy that drives convection with the atmosphere and ocean, producing winds and ocean currents. The sun is the source of most of the heat energy on Earth. Earth from the sun travels through space and enters the Earth system through the atmosphere. The heat energy from the sun provides the fuel for Earth's weather. Again, we will play these videos in class. Since the Earth is tilted on its axis, areas of Earth do not receive heat energy equally. The equator receives more direct energy while the poles receive much less. This uneven heating causes differences in temperature and pressure of large air masses. Because of these differences, areas of warm air rise while cooler air sinks. This pattern of circulation is called convection. So here you see convection in the air causing winds, where again land heats up faster so that warm air rises, and then cool air sinks over the ocean or a lake. Convection creates Earth's weather. Think about what happens when you blow on hot cocoa to cool it off. The surface of the hot cocoa moves in the direction of your breath. Winds move ocean water in similar ways, creating surface currents. Surface currents are driven by winds that blow for long distances over the ocean's surfaces, distributing heat energy around the globe. Earth is rotating, so winds blow in a curved path. Since the winds move in a curved path, so do ocean surface currents. The Coriolis effect has a crucial impact on ocean currents and wind directions. This effect is also called the Coriolis effect or Coriolis force. Winds or waters that originate near the poles carry high pressure cold air and cold water. Winds or waters that flow from near the equator transport low pressure warm air and warm water. So for our exit today, it's a STAR test question. A student models convection currents in a laboratory activity. How are the convection currents in the student's model different from convection currents in Earth's atmosphere and ocean? So here, if you look at the beaker on the hot plate, your heat source is coming from the bottom. So you have that warm water rising, cool water sinking, creating convection. If we look at convection happening in our atmosphere, it's the sun that heats the land and warm air rises and cool air sinks. So the heat source for Earth's atmosphere and ocean is the sun, which heats from above instead of below. So again, here in this model, your heat source is coming from below.